Okay, so I'm going to talk about question 6b from the skills section part of the homework, because that seems to be one of the ones that causes most problems. So what we've got is 2 sine theta cos theta add sine theta is equal to 0. So a lot of us initially looked at this one and started to maybe try and rearrange it, etc. But the trick to this one was to factorise out your sine theta. So if we factorise that out, we get 2 cos theta plus 1 goes in there, and that equals to 0. Okay? Now it's very tempting at this point to divide both sides by sine theta and then get a nice easy equation to solve, but we have to be very, very careful when dividing by sine theta, because sine theta could be equal to 0. As we know, at some points in the curve it goes through 0, so we don't ever want to do that. We always want to check if sine theta could or couldn't be 0. In this one it can't, so don't be tempted. And the same way that if we had x multiplied by 2x plus 1 equals to 0, we would know that x could equal 0 or x could equal minus a half. It's exactly the same process here. So either sine theta equals to 0, or from this one, using the same kind of process, cos theta equals to negative a half. Then we've got 2 paths that we want to follow to make sure we get all the solutions. So this one should be reasonably straightforward. We think about our sine theta between 0 and 360. We think about what values of theta that could be. So it could either be 0, 180, or 360 degrees. Then we're going to have to follow down this route as well. So inverse cos your minus a half, and you get square minus a cos minus a half. Inverse cos, is it a special one? It's not, is it?
Yeah.
Minus 0.5. It is 2/3 pi, because I'm in radians and I don't need it to be. So 60 degrees. 120 degrees. 120 degrees. So, we've got 120 degrees, but again, we want to draw a quick graph of cos between 0 and 360 to just double check that we're on the right path. So our 120 degrees makes sense that it equal to a minus a half. So we also know there's another solution there. So the way that I would do this is think about the sort of symmetry that's coming in from the graph from the point of 360 degrees inwards. So if that one is 120 degrees, it must be the same back that way. So the other one is 360 minus 120, 240 degrees. So we get all of our solutions. And we just need to double check, because I think, if I remember rightly, I'm just a little bit cautious of this 0 and this 360, and I just want to make sure that I definitely copied down whether or not I'm allowed to include 0 and 360 correctly from the question, and I have. So we should have a total of 5 solutions for that. But what you'll notice is that if you did divide by sine theta at this point, you would have lost all of these 3. So I think that was probably the most common mistake made. So watch out for that one. So I'm going to set a couple of very similar ones that are going to involve this factorisation technique. Remember, be very careful when it equals to 0, you can't really divide by any of them in any case. Yes, because it could always equal to 0. There we go. Right, Mrs. Squire, as you're here, do you have any tips of advice for students on these kind of questions?
I think just if in doubt, factorise, never divide.
Yeah, never divide unless
it's like...
You can if you've got like a 3 sine theta equals 4 cos theta.
Because theta's never... There's not a value of
It's
theta.
not a value that would ever work.
0.
Yeah, because if you were to write it as 3 sine theta minus 4 cos theta, if, say, sine theta was 0, cos theta would have to be either 1 or minus 1, and it would never work, because you would end up with like 4 equals 0 or something like that. So in this case, you can divide by cos theta, but as a rule, never. out for that one. I hope that helps.